In the last video, we saw that finding the length of an arc was basically finding the length of a fraction of a circle. So it ended up being a fraction of the circumference. Let's see if we can use the same reasoning to find the area of a sector. So you see in your notes that we have the vocabulary for what is a sector. And in the simplest terms that I can possibly think of, a sector of a circle is like a slice of pie, slice of pizza. Okay. So first thing I'm going to do if I'm trying to find the area of sector AOB is to find the area of the circle. So they gave me that the radius is 15, so 15 squared is 225. So the area of the circle is 225 pi. Now the entire circle is 360 degrees, but the measure of angle AOB is 120. So the sector's area will be 120 over 360, or 1/3 of the circle's area. So the area of the sector will be 1/3 times 225 pi. And so I get my calculator and I take 1/3 of 225 pi, so 225 divided by 3 is 75. And they want us to go ahead and evaluate this. To 35.5. So the area of sector AOB is 75 pi, or 235.5 square millimeters. How could we use the above process to find the area of a sector whose central angle measures m? So we could take the m over 360 and multiply it times the area of the circle. So what would be a formula for the area of a sector? It would be m over 360 times pi r squared. And lo and behold, that's the exact same thing that you have here in your text. So you see in example 1 part A that we're using that formula. They've taken the 210, put it over 360, reduced the fraction, found the area of the circle to be 9 pi, multiply them together, and evaluate it. For part B, our arc measure is 131. The radius is 12. 131 over 360 doesn't reduce, so I'm just going to kind of carry that around like luggage. 131 over 360 times 144 pi. And 131 times 144 divided by 360 is 52.4 times pi. And when I evaluate that, I get 164.5. Your friend says that the value of m in this formula can never be larger than 360. Do we agree or disagree? Well, remember what the m represents. The m represents the angle here. Well, remember, there's 360 degrees around the circle, so we agree. There's only 360 degrees in a circle, so a sector greater than that is impossible. couple more examples using this formula. So M in arc AOB, sector AOB, that's 180. So 180 over 360 times pi times r squared. And that's a 1.6. It's hard to see on my screen, but it should be clearer in your book. So it's 0.8 squared. So 1/2 of 0.64 pi, which is 0.32 pi. And when we evaluate that, 0.32 times 3.14. Actually, let me use my pi button instead. So 0.32 times pi is 1.01 square centimeters. In number 5, 22.5 over 360 times pi times 24 squared. 22.5 over 360 is 1/16. And 24 squared is 576, and then pi. So 576 divided by 16, oh, that's 36. So 36 pi is my first answer, and then when I evaluate that, I have 36 times pi, and that is 113.10 square millimeters. So let's see how we can use this in real-world problems. In example 2, we have a beam from a lighthouse, and they're asking us what is the area covered by the beam as it sweeps an arc of 150 degrees. And so we have the 150 over 360 reduces to 5/12 times the area of the circle is 9 pi, and then they evaluated that. I have a circular plot in part B with a 180-foot diameter. So right away, I'm going to write down that my R is 90, so I don't do something foolish like plug in 180 for R. And it's watered by a irrigation system to the nearest square foot. What is the area that is watered as the sprinkler rotates through an angle of 50? So, oh look, first thing they ask me is, what is R? I put the 50 over 360 times pi times 90 squared. 50 over 360 just reduces to 5 over 36 times, this is 8100 pi. And so when I multiply that 8100 pi times 536, 8100 times 5 divided by 36, it is 112.5 pi. And when I evaluate that pi, I get 353. Because the instructions ask me to round to the nearest square foot. That's why I'm rounding to the nearest whole number here. Last example, very much like the last one, the sprinkler is rotating through a semicircle. So my R is still 90. My A is, I'm sorry, not A, M. My M is 180. So 180 over 360 times 8100 pi. 180 over 360 reduces to 1/2 of this 8100 pi, which is 4050 pi. And when we evaluate that, we get 12,723. What were the units? Square feet.